In the last video, we learned how to use the Gauss-Jordan elimination method to calculate the inverse matrix of a matrix. In this video, we'll learn how to use determinants to calculate the inverse matrix. Assume we have the matrix A, and we'll just write down the entries. The first entry being A11, then A12, A13, etc. And the last entry of the first row is A1n. Then we carry this on in the second row. Assume we have n rows. Then the first entry of the last row will be an1, then an2. And the very last entry of the matrix is ann. Then there is a formula to calculate the inverse matrix of A, which is equal to 1 over the determinant of A multiplied by a matrix. In the matrix, the first entry is C11. In the first row, second matrix is C21, C31 to Cn1. For the second row, it will be C12, then C22, C32, then Cn2. Let's skip to the very last row. The first entry of the last row is C1n, then C2n. And the last entry of the new matrix is Cnn. There are two things I'd like to talk about here. The first is C is called the cofactor. The second thing is, if we pay close attention to the entries, you can see the orders are switched. In the original matrix, in the first row, second entry is A12, but in the new matrix, the first row, second entry is C21. For the 2x2 matrices, there is an even simpler formula. So if the matrix has entries A11, A12, A21, A22, then the inverse matrix is 1 over the determinant of A multiplied by the matrix A22 minus A12 minus A21, A11. Let's look at one example. Assume we have a matrix A, that's 3, 1, 2, 4. The question asks you to calculate the inverse matrix of A. We can directly use the formula above. So A inverse is equal to 1 over the determinant of A. Then A22 is 4. Minus A12 is minus 1. Minus A21 is minus 2. Then 3. For the determinant of A, it's pretty straightforward. We've learned it from a previous video. So this is simply 3 times 4 minus 1 times 2. So that's 12 minus 2. That gives us 10. And this can be written down as 1 over 10. 4 minus 1 minus 2, 3. Let's put the 1/10 in the matrix. That gives us 0.4 minus 0.1 minus 0.2 and 0.3. And this matrix is the inverse matrix of A. How about a 3x3 matrix? Again, the first thing we're going to do is to calculate the determinant of A. I will not expand the calculation here, and we'll just write down the solution. It's again equals to 10. The next part is a bit tricky, is to calculate the cofactors. In fact, the calculation of cofactors is somewhat similar to the calculation of determinant in the 3x3 matrix. Before looking at the first entry, we'll write down A again. Since we're looking for the value for C11, we'll identify A11 first, then block the row, block the column, and the cofactor of C11 is the determinant of -1, 1, 3, 4. The next entry is C21. Note it's not C12 because the orders got switched. So C21 is in the first row, second column. In the original matrix A, the entry for A21 is here, corresponding to C21. Then we need to block the row and block the column. So the matrix we have is 1, 2, 3, 4. Because the signs are alternating, so we need to put a negative sign in front, and this gives us 2. We can repeat the same process to calculate C31. The corresponding entry in the A matrix, A31 is here. So let's again block the row and the column. The matrix we have left here is 1, 2, -1, and 1. Then we get the determinant of that. In this case, the sign is back to positive, and this gives you 3. From this pattern, you know the next entry will be negative, the one after that will be positive, and it's alternating. So based on what we have here, let's just write down part of the inverse matrix. The determinant is 10, so we have 1/10 in the front, and we have the first row here, that's -7, 2, 3. We can repeat the process to calculate the rest of the entries. I'll just write down the solution, and the final form for the inverse matrix is, and this is the inverse matrix of A. Before we wrap up the matrices topic, we want to recap what we have learned so far. If we put everything in the big picture, there are 2 types of problems we like to solve. The first is to obtain the solutions for linear equations. The second thing we like to do is to calculate the inverse matrix. For both problems, there are 2 methods. The first method is to use the Gauss elimination method or Gauss-Jordan elimination method. The second is to use the determinants. So on the left-hand side, we have the problems we want to solve, and on the right-hand side, we have the tools we can solve these problems. In the next topic, we'll move to a more advanced level of matrices. We'll focus on eigenvectors and eigenvalues.